Okay, okay. Good. We are on. So, good morning, everyone. Welcome to this meetup. So, this happens to be our monthly meetup where we meet, we talk about Microsoft Azure, .NET, and other technologies too. Um, Today, we are going to talk about how we can even get started with .NET and Azure. We have amazing speakers who are going to speak to us how we can leverage these technologies um, whilst we are, foster our technology life or our career. So, um, if you are not part of the user group, if you are new, we have a WhatsApp group where we share ideas. So after this meetup, you can contact us and then we will add you. And then we also have a meetup. You can also join us on the meetup platform. So we also have a LinkedIn page. We have S account and all that. You can follow us in case of any updates. You are going to get it there. We have a YouTube channel where after every event we just upload it there so that in your free time you can go there and you can watch and all that. So that is also very helpful. So after this event, this video or this event is going to be on our YouTube channel where you can go and then in your free time you can make reference or you can watch it. So once again, welcome to this meetup. So today we have amazing speakers with a lot of experience going to speak to us. So without okay, someone want to join. So okay, we have Michael is joining. Okay. Okay, so welcome, Michael and James. So we are yet to start. And so first on our list, we have Peter Samwa. He's going to speak to us about how we can get started with testing in .NET. So say if you can hear me, you can take the lead and then start give us the insight. Yeah.
Cool.
Yeah.
I don't know if you can hear me. Can you
Yeah,
hear
we
me
can hear
clearly?
you. Yeah,
Okay.
yeah, I can
Yeah,
hear you.
Fine.
Yeah.
Yeah.
uh,
yeah, just
I
fine.
think
yeah.
yeah, I think I'm having some issues with my camera, so I'll just whenever the camera comes back on, I'll let you know. But
Yeah,
I
yeah,
would
it's
like to
fine.
share my screen. So let me share my screen.
Okay.
So it is nice to sort of like it's my first time presenting. I think I've been part of the .NET WhatsApp group for a while, but I haven't actually really taken part in the meetups and other programs that have been. Partly because I'm not around much, and also because sometimes, sincerely, I think I'm a bit lazy as well. But I just thought I saw the post from Clifford on this. Well done, thanks. For inviting me and accepting my invite to give a very short talk on testing. So, you know, I only have 25 minutes, 20 minutes for this, so I will just get right to it and try and cover as much as I can. Are you able to see my screen? I'm sharing my screen. Should be
Yes.
familiar
Yeah.
screen. It's just Visual Studio with a project called Hello Testing. Um, so, what is testing in software engineering? So, testing is, a very simple definition for testing is it's the only way to know how your application works. It's something that a lot of developers do, um, whether it's either by running your application after you build it or by going through some of the testing techniques that I'll be discussing today. I'm sure most of you, some of you will have written applications, big applications, large applications. You may have written tests. So take this as sort of like a refresher for those who haven't, who are still new to it. I'll do my best to explain. And also, if you want access to sample code, which is just a couple of snippets of code that I wrote to cover, what actual testing is, feel free to reach out to me and I'll give that to you. So I just want to give you a brief introduction to testing, just a bit of literature to understand, why it's necessary, why do we do this, what sort of testing is out there, and then after that, circle back into what testing in .NET, looks like. So in terms of testing, we do have the two main forms of testing that we have are functional testing and non-functional testing. So in functional testing, we have unit testing, which basically involves testing individual components of the application. So what I mean by individual components of the application means component level of the application in terms of methods, in terms of tiny snippets of code, in terms of functions that you write in your application. Testing, that is what unit testing does. It covers, or it makes sure that you are sure that these bits, these tiny bits and bobs of the application that you've written work very well. And the second well-known type of functional testing is integration testing. So integration testing deals with testing how different and multiple high-level components, right, of the application work together. So if you build a desktop application, how does that desktop application work with a database or a network? If you build a web application, how does that web application work with a database or a server, or how does it integrate with other components that give that business value that you are building the application for? So a lot of the testing that developers mainly do are functional testing, but I think that it's important to highlight other bits of testing that you may come across, in your development career. So like non-functional testing, such as load testing. Um, some developers do load testing, but normally in larger organizations, those may be outsourced to quality assurance engineers, or it may be, given to, QAs. It doesn't always sit within developer scope because it doesn't really test the functionality that developers have written. It rather tests your applications against metrics such as performance and other things, which depending on your organization, because it is really organization oriented, depending on the organization that you work for, that domain or making sure that that bit works may sit, within the scope of developers or within the scope of maybe DevOps or quality assurance engineers. So other forms of non-functional testing are A/B testing, which is where you release two versions of your applications to test how the market reacts to it. So you could have a front-end UI where you release two versions of it to see which version drives traffic to your website. So you could be maybe a credit card application company and you could have two different forms, and depending on which form that users find very easy to complete an acquisition journey, that is sort of like what works for you. And there is user accepted testing. So I'm sure most of you may have come across the term UAT, which is user accepted. I think within the developer scope, it's sort of like an environment for us, but it is actually a testing environment where user accepted quality assurance engineers will sit down and test different forms of testing that automation tests do not cover. So they would test how the actual user will use the application, not just a machine automated program that may miss out certain sort of like user experience, features that may have been missed when developing. So now let's circle back to .NET. So for the scope of this talk, I'm just going to focus on unit testing, mainly because it is sort of like the fundamental, most beginner entry level into testing. If we do have other talks, I may dive into integration testing and maybe a bit of load testing as well. So what tools are available in .NET for unit testing? Well, Microsoft provides XUnit, which is the most used unit testing tool, arguably, depending on who you ask. There is an open source one called NUnit as well, and MOQ, which is a tool I'll highlight on later. Controversially enough, some people may not want to use it now because if you've been following the news of open source, it fell out of favor recently. But there are other options like NSubstitute that you can use for mocking. I'll talk about mocking when we start looking at some code. And Visual Studio. So Visual Studio is mainly for functional testing, which I'll demonstrate very soon. And also the .NET CLI, which is where you can run test as part of your CI/CD pipeline. If you run testing, integration testing, or unit testing as part of your CI/CD pipeline. So why is unit testing important? Well, automating functional tests at the component level. So whenever you write a bit of code, instead of clicking run every single time to test, you could simply just execute a unit test and it will run those tests for you. It speeds up production, it speeds up delivery of code, and it's sort of like the ideal way to write code to test your features very quickly. So it also provides a way to test code to make sure that whatever new changes that you added did not, did not introduce any breaking changes. So let's say you had a feature and you made some changes. You want the code to work exactly how it wanted if the feature did not really change anything. Maybe you did a bit of refactoring because you wanted to improve some performance. The core functionality did not change. So the unit test helps provide sanity in that situation where when you execute a unit test, it basically just still works because you didn't actually change the core functionality. So unit test also helps you document your code. So if you've worked in any new organization or you've switched companies to a different company, sometimes when you pick up some code, it just looks foreign to you. Unit testing can be a way to self-document code because the test assets and also provides, it provides functionality. It explains how the functionality works by going through the test. If you pick up any open source library or any, third-party code, sometimes going through the unit test helps you understand what, how the open source library works. Or if you pick up, if you go to the Microsoft page and you pick up, some of Microsoft's sample code, they provide test scenarios to try and recreate the functionality to help you understand. Also, writing test leads to clean code. So testable code is properly written code or clean code. Normally, when you write code and you can't test it, it means you probably haven't written it properly. So sometimes whenever you write a bit of code, you realize that when you try to test this code, it's very hard to test. That should be a red flag. That should let you know that, oh look, maybe I'm not doing something right. I need to sort of like, try and fix this well so that I can test it properly. So we'll see a scenario like that in the demo. Okay, so on the chapter 4 and 5, I'm just going to dive straight into some code to try and help you understand everything that we're talking about. Um, so I'm just going to first start with some very simple functional testing. So I already said that one of the first ways that you can test code is just by functional testing. And I'm sure we do that every single day. You write some code, which is in that case console.writeline hello testing, and then you run it to make sure that the code works. So in this case, I just wrote some code called console.writeline hello testing. All that does is that it prints, to the screen that hello testing, and that works. So this is functional testing. Everyone does this every single time. It's a way to know that your code works. Normally, you will not write code and not run it because you need to run it to make sure that the code works. So that is functional testing. And it's something that we all do every day. But how can we automate, these tests? Let's say I wanted to test. Let's take something a bit more simple or a bit more complex. So I wrote this very simple class, which is a calculator. All it does is that it takes a value x and a value y, and then it takes an operator, and then it does some computation, and then it returns the output. So, I wrote this because probably maybe I got a job at, I don't know, Casio, and they asked me to write this. So, it's my first day on the job, and my manager says I should write this. So, you know, I just want to test this right now. So I want to make sure that my application works. I know 2 plus 2 is 4, so let's try that. So I'm just going to create double xy, double y2, and then, oh, all right. And then I'm just going to check the result that my calculator works. We're just going to call calculator, calculate. I'm going to pass 2 in there. I'm going to pass 2 in there, and I'm going to add a star operator. And I just wrote this morning, so if it doesn't work, forgive me. And so, I mean, I think we all know that 2 plus 2 is, oh, see, I actually didn't pass the values. Okay. So we all know that 2 plus 2 is 4, right? So, I mean, let's find out if this is working. So, yeah, I got 4. Let's try something else. Let's get 2 plus 3. I'll expect that to be 5. Let's try with 2 minus, right? Well, 2 minus 3 is minus 1, right? Yeah, it is minus 1. Let's try with multiplication. Oh, it's 6, so that's working. So let's try with division. Don't know if that is a division sign. Oh, look, 0.66. That is working as well. Let's try with modulos. 2 more 3. What's that? Oh, 2 more 3 is 2. I'm not expecting modulus, but yeah, I'll note out that computer. So let's try with some random thing like a bracket. I'll expect an exception. Well, that's an exception, yes, because operator not supported. Well, how do we test this then? I mean, we know how we can functionally test this, right? Because we can simply just run every single scenario and we will get results, right? But we want to test this to make sure that, we want to automate this because, my manager says he doesn't want to have to run every single scenario in there. He wants to be able to just, automate this whole process and also try it for different things. Maybe try it for 100, try it for, 100 times. What was that 300? He wants to. So let's look at writing some unit tests right now. So when you're writing unit tests, the first thing is that you need to identify the scenarios that require testing. Even before you pick up some code, even before you dive into it, you first need to identify, okay, what scenarios require testing. In this simple calculator application, we know that we want to test how the operators, right, interact with these values. So just off the head, I think that we have our scenarios should be the n number of operators, right, which is about 6, addition, minus, multiplication, division, modulos, and also an operator where we do not find it, right? So first, let's go back to the tools. We know that Microsoft uses a lot of tools, and if most of you have not done this before, well, the first thing that I do is that I'm going to create a new testing project. I don't need to create a new testing project to do this. It is important. I can just add the testing libraries, right, to my current project, but it's just best practice to always separate your test from your main application project so that way, whenever you are setting these tests as part of a pipeline or as part of an integration pipeline, you can run the test project separately. So it's something that I'll advise that you do, not something that I'll say that you should do, but then it's just best practice. Best practice is just a guideline, but that is how just the industry does it. So I'm just going to go to my new project and then I'm just going to type testing to see what Microsoft has for me. Oh, test. So there are quite a number of projects here. There's MS Test, which I'll advise that don't use because it's very old and no one uses it anymore. There's NUnit Test, which is open source, but Microsoft has integrated this as part of it. And there is XUnit Test. So I'm going to use NUnit Test because it's what I use at my company and it's what I'm used to using. And I'm just going to call this hello testing dot unit dot test. So, I mean, someone may ask, okay, why are you calling this hello testing dot unit dot test? Well, it's just a naming convention. Different people call it different names. You can call yours hello testing dot tests or hello testing dot unit tests or hello testing dot. It's just a naming convention. So not a strict, sort of like, paradigm that you should follow. So what that does is that adds a lot of boilerplate code for me that I don't need to add. For example, it adds all the packages that I need, which is NUnit, Microsoft Test SDK, NUnit analyzers, test adapter as well. Also sets up the NUnit framework global usings for me. Okay, so I'm just going to rebuild the application to make sure that everything is working fine, just as sort of like a sanity test. So just a bit of functional testing there as well. Um, The first thing I'm going to do is that I want my test project to have access to the code I'm going to test. So I'm going to add a project reference, right, of the hello testing to my test project. So that way it has access to these classes, this calculator class that I want to test. So what does the structure of an NUnit test look like? Well, first, you have a setup class. Think of the setup class of an NUnit test as a constructor. So it allows you to set up all your dependencies. And if you don't remember what I said about NUnit test, what you can do is that you can just type NUnit and then go to docs and you get all the documentations here. So it is sort of like well documented. Or if you don't want to look at the documentation, you can just hover over setup and then it tells you exactly what it does. So the setup class identifies as a method to be called immediately before each test is run. So how does the NUnit class know, which method is a test? Well, it uses attributes. I'm sure for those of you who are new to .NET and aren't sure what attributes are just sort of like modifiers on methods, and the syntax is normally written like this, where you have a square bracket and the name test in there. So that's how that works. So another thing that I'm going to add, another package that I'm going to add, which I recommend, but say that it's not something that you need to use if you don't want to, is a package called Fluent Assertions. So Fluent Assertions is a package that helps you assert, which I'll sort of like explain very soon what that means, right? So I'm just going to install that. I'm hoping that most of you understand the installing process that I'm doing, so it's not anything new. So normally, well, not normally, most tests, right, follow a very simple sort of like formula, right, where you have initiate. I mean, I'm calling it initiate because different people call it different things, and you may see it called different names. But basically, initiate is where you do what you want to do. Basically, where you call the method or where you get your results or something like that, right? Or set up your variables and stuff, right? And then the next bit, right, is compute. Compute is where you call the method, whether it's whatever testing that you're, whatever method that you are calling, and the next bit is accept. So these it's very important to know that these may be called something completely different when you have a look online or what do you call it? You have a look online and you see something different. Don't like sort of like feel like, oh, maybe this is how you need to do it. But I call it this way because it's a lot simpler for me to sort of like understand. Because initiate means I initialize some variables. Compute means that I execute something. Assert means that I assert that the results are the same. But the formula is still the same across every single application. I feel like the reason why I stress on this is that you do have a lot of developers who argue over this, that, oh, it should be called this. And I feel like that is quite pointless. The focus should be on what it actually does and what is being achieved at that point. So I'm just going to write a very simple test. So let's write a very simple test just to test this approach. So I'm going to say, well, string name is Peter. So I'm initializing a string name to the name Peter, right? And then I'm going to say number of letters or name count. Sorry, that's name dot length, right? And then I'm going to assert, right, that name count dot should be. Sorry, how many letters are in there? 5. Should be 5. Okay. So this is a very simple test. I initialize a variable called name. I get a length, which is the computation I'm doing, right? And then I basically assert that, okay, look, this name count should be 5, right? So how do you execute this? How do you test to make sure that this is working? Well, Visual Studio is your friend, and on the Visual Studio tabs at the top, there is a tab called Test. When you click that, you can click Test Explorer. So what Test Explorer will do is that it will scan your application, right? And then find, I like to just snip it at the back this way, so that way I can see the code as well as the testing. But what it does is that it scans your testing projects, or it scans your solution to find all of the projects that are test projects, and then it sort of like points them out to you. So it scanned my solution, found this project, which is help unit test, found the namespace, which is help unit test. Within that namespace, it found a class, which is called tests. And within that class, it found a test called test1. So all you have to do is just click that. So what that will do is I will build application, and then it will execute the test for you. So this is how we automate the test. This is a simple procedure behind it. So I didn't really need a setup class because there was no point in setting up anything. I also simply just called my test here because it was, I just wrote a very simple test to, you know, demonstrate how the NUnit framework is used for testing combined with Fluent assertions. So it should be a sort of like from the library Fluent assertions. It really helps you write tests. What it does is that it just gives you this nice synthetic approach of reading your test, where when someone picks this up, assert pass may not seem even though it's readable, it may not feel fluent, or it doesn't feel like normal English. And what Fluent assertions does is that it gives you syntax to be able to write asserts, right? Using simple English. That's what it does. It basically just allows you to write it using very simple English. And it has a whole lot of methods that, allow, you to, make this, work really well. So let's take this little bit of knowledge, right? And use that to write tests for our calculator class. So I'm going to create a class called calculator tests, right? So I'm just in my testing class, in my testing project, I'm going to create a class called calculator tests. And I want to test 6 scenarios because, as I said, the first thing is to identify the number of scenarios that you want to test. I want to test, if I was testing this functionally, I'll put in, as you saw, as I did in the program, I was just changing the operator and passing different values just to make sure that it works. But I want to automate that whole process. I don't want to have to be changing this value. It's a whole lot of work. So what I'm going to do is that I'm just going to try and automate all of these processes at once without having to, write all of that and run the program every single time. So I'm just going to copy and paste all of the stuff here because, developers, copying and pasting is a very powerful skill. So I don't have to, do any of, repeat all of that. I'm going to change that. I don't need a setup class. I'm just going to get rid of that. And so what I'm going to do is that the first thing I'm going to do, as I said, is to write all my scenarios. So first, I want to test addition. Again, so when you pick up other bits of code or code in your company, different people have different ways of writing these scenario methods. Depending on where you work or depending on the team that you work with, you may see scenarios like, okay, you may see people who may write descriptive scenarios, such as when value is that, result should be this. The approach that I normally use is I just use test scenario and I just add a scenario because it's a lot easier for me to read that way. But it doesn't mean that this is how you should do it. It is very, very opinionated in terms of how you want to do this. And different companies and different engineers have different ways of going about it, but the principle is still the same. Is that you write a test method that is readable. When someone picks up your test code, they need to be able to understand that this is what this test is doing. This ties into what we had in the notes, that unit test documents code. So when someone picks up your unit test for, a calculator, they need to be able to understand what every single bit of test is doing. It has to be able to tie into the code so that the code becomes self-documenting. Okay, so I just want to test addition first. So I'm going to write out my scenario. So test scenario and calculator addition. And I'm just going to copy in that. And then I'm going to say test scenario, calculator subtraction. And I think you can get sort of, I guess, the rest. Test scenario, calculator multiplication, and then test scenario, calculator division, and test scenario, calculator modulo, and then test scenario, calculator unknown up, which is unknown operator. Okay, so I'm just going to check this here so that way the screen is a lot more visible. Okay, I'm just going to open my calculator code, and I'm going to put that on the side here because it's a lot easier for me to see, and then I'm just going to put that here. Okay, so the first scenario is addition. So I'm going to initialize some variables, which is x, which is 2, and integer y, which is 3. Oh, sorry, I'm going to use doubles because these are calculated, so integers are supported, decimals are supported, right? And then I'm going to get compute and get a result. So compute and get a result, so it's just x and y, and sorry, I'm going to pass an operator addition, right? And I'm going to assert that the result should be, I know that when I add this, it should be 5. So I'm going to say the result should be 5. And I'm just going to copy and paste all of that here and just edit that. So test subtraction, I'm just going to say maybe 5 and 3. And then that should be 2. And I'm going to copy that. And then I'm going to paste that here. And I'm saying test multiplication, 5 and 3 should be 15. And then test division, I'll say 6 and 3. That should be 2. And then I'll say test modulo. I actually don't know what 6 mod 3 is. But let's see. I'll leave that and let the test fail. I think this will be 0. I don't know. Let's find out. And then unknown. So I'll just grab that. And then in the results, I'll say should be of type. Oh wait, sorry. So this will throw an exception. Oh, there's a way to do this. This is a bit complex. There's a way to do this. Results. Sorry, just for time's sake, because I'm being told that my time is almost up. Let me comment this out. Let me run this for now. Okay, so I covered addition, subtraction, multiplication, division, modulo, and the exception case. I'll add exception to this version. So first, what I'll do is I'll rebuild my project. What I'll do is that this will let me know that the tests have been added. If you have a look at the test console, which is what we got from the test tab, you can see that the test scenarios have been added. And I mean, if I still got my basic math right, I think that this should be the expected for every single one of those. And so with very little confidence, I'm just going to run that. Oh wow, look, all of those scenarios, right? So this is basically an introduction to testing. Just a sort of like a very, very high level, introduction to exception and um, very high level introduction to unit testing. It follows a very simple principle where first identify the scenarios from whatever method that you write. In my case, well, it was a very simple calculator method that just adds, subtracts values, throws an exception. Even when it's interested in the exception part, I can show them. I don't want to confuse you guys a bit if you're not used to actions and lambdas and delegates, because I do basically what I need to do is I need to get a delegate and accept that the delegate will throw an exception when called. But I don't want to, I want the focus to be on testing, not to move away from other .NET features that may throw a bit of confusion in there. So this is just my introduction to testing. I hope that with the little time that I had, you would have got a bit of knowledge from this. And yeah, if anyone has questions, they should let me know. Thank you.
Okay. So thank you so much. This is very insightful. Yeah, please. So if you have a question at this point, you can ask your question and you'll be ready to answer you. You can unmute yourself and then talk, or you can then put that question on the chat. So I'm guessing that there is no questions for now. So okay.
No question at all. If there's no question at all, Peter, if you have a couple of questions, you can throw it to the crowd and let's see if everybody's okay.
So I guess the question is that is testing or writing unit tests something that most of you do as part of your applications, or is this the first time that you've been introduced to this concept? Is it a concept that you are used to? And the sort of applications that you build, do you break them down into tiny units and unit test them, or is this a new term? I guess that's my first question. Yeah.
Yeah. So Clifford, please go through your attendees and let's see if you have some answers for that.
Yes. So yeah, I have some people here.
Can
I
I
have Dennis.
make a comment?
Yeah. Dennis, go ahead. Yeah.
Okay. Yeah. So, in my organization, there's a section that is like actively trying to develop, apps using Microsoft applications, to help automate office processes. And with my organization, there are a lot of processes, so many of them, but those processes are very key. And I think for me, this is the first time that I'm hearing of the unit testing. You think what you are doing when you just build an application to perform a particular task based on the requirements that let's say in my case, the users in the department would use. But you wouldn't think that you have to take the time to thoroughly test these things. So one of the things I realized was there's always a back and forth, and there's always oh, can you change this? Can you do that? That kind of thing. So this whole idea with the unit testing I think is something that is new to me, and it's interesting that we have that aspect of the programming side that should at least help us rather produce a much more, if not perfect, but like an efficient product. In solving some of the problems we have. Yeah. Thank you.
Yeah. No worries. Yeah, that makes perfect sense. Yeah. That is the whole point of testing, is to make sure that your application works the way you want it to work, and even with changing requirements, you always understand that when you add new changes, it doesn't break existing changes, and it's sort of like, it gives you that sanity. Yeah. Cool. That's cool.
Yeah. So I think there is another question from Sir Frank. I think you want to. Yeah. So Sir, you can go ahead. Yeah.
Yeah. So it's more like a contribution.
Yeah.
As software engineers, testing is part of the software development lifecycle. So it's something that we cannot keep out of our process. So for all engineers on the call, once you know that you are building a product, it goes through a life cycle where there's plan stage, design, development. There's also testing. So it's one part that we cannot keep out. So just like we have our physical products or other products or non-software products like vehicles and the machines or gadgets that we use, they also go through testing. That's why we are able to use them. Anytime you turn on your television, you are expecting it to work, right? Anytime you buy a new car, you're expecting it to drive. So it's the same way when somebody uses an application that you've built, they're also expecting it to work. And the way that you can put these measures in all the you've written, right? Because the functions that make up the functionality of the product at the end of the day. So tested is something that we need to, always keep as a best practice as a software engineer. So yeah, just a little contribution, to add to what Peter, presented.
Okay.
Awesome.
Okay.
Nice.
Okay.
Okay.
Yeah. Thank you, sir. So is there another question or contribution? Yeah. Yeah. So if you have a contribution or question, you can go ahead and then do that. I think at this. Yeah.
Yeah. So if you have any other contribution or mostly a question, you can just reach out to me on the chat, and I'll do my best to answer it. So I will stop sharing my screen and hand over to the next user, next
Okay.
presenter. Yeah.
Okay. So thank you so much. Yeah. So next on our list we have Sir Wise. He's going to present to us on how we can automate NuGet package deployment. So Sir, if you can hear me, you can go ahead and then do the presentation for us. Yeah.
Let's manage the wise like that. That's said, yeah. I'm not a knight of the kingdom. I'm not a knight of the kingdom yet. Anyway, hello everyone. Am I audible? Can you hear me?
Yes. On my side, I can hear you.
All right, cool. So, hello, my name is Wise Duho. I'm currently at Haptel. I build libraries for a living. Inside the organization, I'm called a senior tool lead engineer. So my job is basically to talk to a team, figure out what they do, and parts of which are externally consumed, and then see how we can externalize those functionalities to the other people who depend on it. So the other people who depend on it will be other clients who use the company's business products, B2B, B2C. It could be your mobile money SDK. It could be anything, right? So over the period, I've picked up a couple of things that I want to share with you. So our focus is going to be the least experienced person. And so those of you already know some of this, we'll still maybe have a couple of things here that you might not have known or you might have overlooked that we could be touching on. So let's talk about building and publishing libraries.
Hey. All right, so I'm going to try as much as possible to make this demo driven. I have a bit of slides though. I have 12 now. I could have kept adding, but not really a slide person. So basically in .NET, we have a number of projects. Class libraries are one of them. And below that is the command for creating a class library in .NET. Basically, that's all you have to do. After that, all you need to do is to add some code that you feel other people are going to depend on. I'll just quickly launch Visual Studio and then we zoom in. Do not recover. Please, is my screen visible or it feels very tiny?
If you can zoom in, I think, yeah, zoom
Okay,
in a
great.
little
Give
bit
me a
for us.
sec.
Yeah.
Let me just zoom stuff real quick. All right, great. So I'll scoot over here. I hope the view is a lot better.
Yes, yes, yes.
So like I said earlier, we could just create a new project and decide that we want to create a class library, and then we pick the language in which we want to create that. And for this use case, we want to use C#. So I could also do this from the command line by using the command I shared earlier. But then I want to start with this. So let's just do that. Let's create our sample library project. So sample library, blah, blah, blah. Yeah, everything is how we want it to be. And of course, for the moment, let's use .NET 8. And so our basic class library should look like this. It should have dependencies on the framework version that we chose. And it should include some default analyzers that Microsoft ships with its products. At this point, I think everything you see here is very familiar and it looks like the everyday code we all write. So I'd also want to show you how that looks like behind the covers. Of course, there are a bunch of things happening underneath here in the .NET SDK. Microsoft is now shipping SDK style projects. So SDK style means that it is going to inherit some of these packages behind the scenes. One of them is the NET Core app. And so that means that you have at your disposal all of these things pre-included for you as part of the project type you have selected as your SDK. But all of these are nicely tucked in under the Microsoft.NET SDK arm and given to you once your project inherits from that. Also, for a library, you would have a number of things. You have these property groups and item groups scattered throughout your code. You have your target framework, and you have some language-specific tags that you can add within your code to give you some additional functionalities based on the version of C# you are using and also based on the version of .NET you are using. But this is not the main focus for today, and so we'll ignore these for now, and we can always talk about them later. So one of the easiest examples I have, which we can build into a library, is to let Copilot generate something for me without thinking too much. And so I want Copilot to generate a repository for me. All right, great. So I have some usable code here. I think this is what I'm looking for. Replace this kindly. Is there anybody here who doesn't understand what a repository is? And throughout the process, if you have a question, you can just quickly alert me, and then I'll just stop and answer that, and we proceed. Any question at this point? Hello.
Yeah, I think we are cool. I don't know. Yeah.
Yeah, looks good.
All right. Okay. So let me just touch on a couple of things to
Yeah, if you can
things.
hold on.
Yeah.
I think there was a question. There was a question on the chat saying, "What is class library?"
Great.
So
What is class library? Okay, so a class library
yeah,
is basically a way to package your application code so that another person can be able to use it. So basically, there are parts of your application you want somebody else to be able to use. You can package it up as a class library and then have them depend on it. If that is not basic enough, I guess a class library is just like how you package your applications to deploy to maybe the Google Store, to deploy to maybe the what's it called, the Apple Store. But this time around, you are not deploying a complete application, but then just a module that somebody else can download and use as part of their application as well. Does that make sense?
yes, I think I don't know whether the question is being answered. So the question. Okay, yes, it says cool. Yeah.
Great.
Okay.
Okay. So let's quickly walk through some of the things that have been generated. I'll just talk through them and we proceed. Why is this? And when is this? Okay. So first we have products. Product is modeling a real life product, and then we have a repository, which is supposed to be a way to create, to update, delete, and fetch the product from a database, right? And then there's the product here as well. Sample library. Why is Visual Studio? Okay. Okay, cool. All right, so this model's a product. It could be any product in your e-commerce or in any solution you are trying to sell or build. And this is the implementation of that repository we talked about earlier. So it allows you to create or handle your product. Okay, there's another question here. All right, so I'm sure, Peter, you can be able to handle that behind the scenes. All right, great. So I have this wonderful e-commerce system that I am building. and I want to ship it out. I want to create a library that other people can be able to use. I have my code. What do I do next, right? So let's get back to our. So we've created this, and then we've added our code to our library. Our library is a bunch of classes, methods, etc. We've added that to the project, and so now we want to make sure we distribute our library to people who are interested in it. So in the .NET world, one of the common ways to distribute that will be to manually ship that, manually give that library to somebody. So one of the ways we can do that would be to just build our project in the first place. So there are a number of errors. Let's correct them as a way of explaining NuGet at the same time. So we go to dependencies and say manage NuGet packages. So in this same way that we are trying to write our application right now, people have also written DS, and there are some common functionalities that everybody is going to need one time or the other that have already been included. That have already been packaged and made available on the internet, right? So Visual Studio gives you a way of being able to access some of these. In the .NET world, we know them as NuGet packages. Currently, my example depends on one of these libraries called Entity Framework Core, right? So I would install this. If you look at the right-hand side, it was built by Microsoft and it's made available under the MIT license. And it has a README. The date published was 29 July for the version I'm using. And there are a number of links, there are a number of tags here that I can use to find this specific library. You see that, well, it is one of the first in the list, so I didn't have to search, but usually when I'm searching and I type in data, ORM, EF core, entity framework, this library should show up. All right, so I'll accept the license terms over here, and then I should be able to install that package as part of my project. So once I install it, you see that most of these errors I was experiencing will go away, and I can be able to import this into my repository, like I was saying, and be able to write what I want to do based on some of these things that have already been made available. Do we have clarity up to this point? All right. So back here in the .NET world, we can make these packages available by simply building our project. So once we build our project, we go to rebuild solution. Rebuild succeeded. If we opened our project in File Explorer, go to the bin debug folder in the framework version, we should be able to see our library and some other files in our bin directory. And the file.dll that has the same name as our library project should be the project that has the details about these classes that have been shared. In a quick minute, let me download this guy. What's his name? So the creators of Rider have a tool. Let me see if I can find it real quick. And the creators of Rider have a tool. Developer tools. is called .peak, right? So let me get .peak real quick, and then we can hopefully it installs quickly. Then we can look at the file that has been created by Visual Studio to see how the code you have can be shared with another team. So .ultimate, let me do the installation real quick, and then we can continue. So .ultimate is, .peak is a free tool, and so you can install it without having to pay anything, and it allows you to take a library code and sort of look behind the scenes to see the code that is actually in it. This can be useful in several environments. Sometimes even for you to be able to learn how to implement some of these libraries that do not have documentation, if their code is not publicly available, you can use this tool to look under the covers to see how some things are implemented, to give you a fair idea of how you should be able to consume those libraries as well. So while this is building, I want to jump to some of the best practices that slide. Some of the best practices that we expect when you are building libraries. So the first one will be that you should version your library. So you should be able to add CS proj. In your CS proj, the version tag allows you to specify that you have released the new version of your library. And on top of that, in the .NET world, we suggest using something called semantic versioning. So semantic versioning says that if you see 1.00 in my version number, it means that it is a major release. I just did one major release, and there's no minor there's no minor release, or there's no patch. So if I release a subsequent update of my library, I'll say it's 1.0.1. That is if the changes I have released are just correcting minor issues that are backward compatible, and I wouldn't really require you to do any change on your end. If you see version 1.1, it means that there are minor changes. You might have to do some refactoring, but it is not major and it wouldn't affect your production code. But then if you see 2.0 from the last 1.0, it means that I have done major changes, and you have to thoroughly consider how it will affect the code you already have in production before you make those changes. Also, the strong naming sort of provides you with what's it called? With a way to make your package visible in the GAC. There's a whole lot of stuff around it, but this is a bit of an advanced concept, and so I've not focused too much on it. And also, you want to be able to include metadata on the package you are sharing, right? So real quick, we can go back to Visual Studio, and I'll show you when we were trying to install that entity framework package. We saw that there's a description of the package. It has commonly used types. It has a version number. It has an author. It has a license section. Oh, come on. It has a license section. And then all of this information, right? These are all metadata concerning your library that have been published as part of your library and can be retrieved by tools like Visual Studio to communicate some additional information to the people who consume the code you are sharing, right? All right. So let's look at .peak. .peak is done now. And so I can run .peak from here, JetBrains.peak. And while it is taking its time to launch, I'll copy the path from here to where my sample library is. And then I'll bring .peak into focus. So right now we have .peak launched, and I want to see the contents of my library, right? So I'll just point .peak to where my library is, select my library, open, and you should see it right in here. It says sample library 1000, like we discussed earlier. And you see that there's a metadata section here. Most of the things here might not be consumable by us, but the framework has a way of using that. We have our root namespace and the various types that were in our project. If you remember correctly, this is, oh, sorry. Not system.web. If you remember correctly, this is coming from the code we wrote within our application, right? So I can put this and Visual Studio side by side. I can put .peak and Visual Studio side by side to show you that actually what we have written is what someone will be seeing, apart from the comments anyway, or someone will be consuming within their application, right? Right. So all of these, just like we wrote in our application, is available in the same way. So essentially, if somebody had my sample library.dll, they would also have the code I have written made available for them to use as part of their product. Make sense? All right. So why don't we proceed by adding in some of the best practices that I have mentioned for some time now. So we can add that by creating another property group. So we have a property group. And then we want to add in our author. And we want to say what's it called? We want to say .NET ACCRA. Right. We want to add something else. We want to add the description. Yeah, Copilot's doing the heavy lifting there. So our description is that it's a sample library for .NET Accra, right? So some of this information, even though not required, becomes metadata that is packaged as part of your application and allows you to communicate some additional information to the people who will be consuming your work. There's a host of them. I might not be able to cover all of them. You can also add package tags, like I said earlier. If we look back in here, if we look back in the package NuGet Explorer over here, we should see some of these package tags appear here, which can help you narrow down your search for the library. Okay, so now we have this, and we may not want to release this library to everybody just as a DLL, right? Over here, we see that they are sharing theirs as NuGet packages, and so we may want to do the same. How do we do that? So there's a command when you right-click on your library called pack. So let's try running pack. It is good to note that you can also do the pack command from the command line, as I have in my notes. I would share that at the end of the presentation for anybody who is interested. So once we've run that pack command, let me just write it again, do that again for good measure. So once we've done that pack command, we should have sample library. We should have our NuGet package created here. So same thing for NuGet package, we have one of these guys called NuGet Package Explorer. So we can open, before opening a local package, let's open one from the online NuGet feed, just like we were seeing in, what's it called? Just like we were seeing in Visual Studio. I want us to use the EF core guy to get the same experience as we're getting in Visual Studio. So we double click to open that. And if we look in here, you can see the package structure of our library. You see the metadata column here, the name, the ID of the package, the version. You see the publisher, you see the verified by. In fact, you see a whole lot of information. Yes, the description also explains some of the things you'll be able to do with the library. And then on the library side of things, you go inside here, you go to .NET 8, and then you see the DLL here, right? So just like we would have shared manually with someone, only now we are packaging this together to be able to share it across the internet for people to be able to consume, right? So now, just like we've opened this guy, let's open our local package as well. So come in here, sample library, go to bin. And we open that for sample library. And you can see from here that we have missing symbols, right? So source link is missing, deterministic blah, blah, blah is missing, compiler flags is missing because we haven't added enough information. But look here, we have a sample library from .NET Accra, and the author is sample library. Right? I think we got the author's flag wrong. So let's fix that and see what happens. So over here, we had it as author instead of artist. So let's save that and rebuild. After we rebuild, we can click here and go to pack. So once that pack is complete, I want to reload this. So just open again, double click on this. And this time around, we see that our authors are .NET Accra and our description is nicely fit in here. All right, great. So we've touched on a number of best practices. There are a host order of them. They are we just looked at package metadata and dependencies. So dependencies are if I am depending on another library. Like right now, I am depending on Entity Framework Core, right? So the best practice is that I have to explicitly declare that in my package that I am building using the package reference so that it will be easy to tell by Visual Studio that I am using this in my code, right? So once I install this package anywhere, it will install or it will attempt to install Entity Framework Core as well if I have an internet connection, or if it can find it locally within my project's scope. And also, let's look at the next best practice. Clifford, how much time do I have left?
Yeah, so basically, I think we have for 2 minutes, something like that, right?
Great.
Yeah. So yeah.
All right. So there's also source link, and just like it says, it enables your users to step through your code, your source code, while debugging. So that's also another very important thing, which I may not touch on, but just take a second to explain. If you are building packages internally, or if your library is open source and people can access the source code, during debugging, you might want to allow people to step through your code as part of what they are doing to enrich their debugging experience, right? It's not just that maybe your library will spit out an error or it will bring back the result of an execution. It can allow your code, the user's code, to actually step through, or the user's debugger to actually step through your code. Doing source link can allow you to achieve that. And of course, documentation and XML comments. And that's the end of the number of best practices that I have covered up in here. So I have touched on all of this. The next thing I would like us to discuss, which my time will not cover, will be a way to do all of these things, but in a declarative form, right? Do all of these things in a way that, just like a Peter's test, we can include it as part of our automated processes to allow you, our automated processes to allow you to automate that process every time. Say there's another version. You don't want to come and be manually increasing that version every time, right? Say you've done a new update. You don't want to manually go and share that to everybody. And so in one of the next times we'll speak, we would look ahead at automating this process. And we'll be using a tool called we'll be using a tool called .NET Nuke or Nuke Build. Nuke Build. So Nuke Build allows you to sort of write platform as code, or to write your automations as code, so that it will run as part of your application processes and be able to build and generate the packages for you, just like we manually did today. And from the code snippet here, you can see that this is a NuGet build process. It does restore, it does compile, which is part of what we've already done. And then it will have other processes such as the pack I did and the publish that we haven't covered, but we'll shortly be covering in our next session. So hopefully, if we are able to make it for our next session, we'll look at publishing to either GitHub. You know, GitHub has a NuGet registry now. So GitHub, NuGet. GitHub has a NuGet registry now. So you can publish to your packages to GitHub if it's a public repository for free. There's also, of course, NuGet.org. So I'm touching on all of these before I go off, so that we are all aware of the various options that are available. If you want to look it up and you do, and you have some questions, I'm always available to help you explore some of these. So there's also NuGet.org, and Microsoft also has Microsoft DevOps. Microsoft also has a private NuGet. It offers to allow you publish packages just like GitHub does. And that one is called Azure Artifacts. Yeah. Thank you for your time today. And I'll take questions if there are any.
Okay, I think there was already a question on the chat. Dennis Asiedu, he was asking, how do you balance between using libraries and writing your own custom code? Yeah, so
How do you balance between using libraries and writing your own custom code?
yeah, and also writing your own custom code.
Yeah, so I'll give this as an example, right? I was working somewhere some time back, and they were using the .NET 4.8, and they were using Entity Framework as part of their work. We needed to write tests. We were doing like a huge overhaul, and there's this package that was allowing us to write the tests using Entity Framework. If you've done something with the old version of Entity Framework before, you realize that it wasn't a prime candidate for testability. In fact, you are not supposed to even be doing testing with direct data access. So there's a whole thing about that. And we needed to find a way of getting it to work. So we got one of these libraries that allows you to specify your database in a file, right? In a CSV file. So it will load that as part of your test, and then it will test against it to see if everything is okay. But it was not reliable. Anytime a new version was released, it will be breaking. So the next thing we did during one weekend was to, because we are in .NET 4.8, it was compatible with .NET Core 3.1, is to move to .NET Core, which had an in-memory provider that we could use to run our tests. And so we rewrote everything sort of to use .NET .NET in-memory provider, so we could be able to run the tests as part of our pipeline. We could have continued using that library, but the cost of maintaining that and that our pipeline would break every time they had a new release and all of that, it made it difficult for us to keep using it. So that's a very good scenario to balance, to find out the balance between, oh, should I keep using this, or I need to change it, or I need to build it myself. That choice, your organizational policies also come into play. Say if it's a tool they are paying so much for, and several other teams are also depending on it, being able to write it out, that wouldn't be that simple in some use cases, right? So, like all good answers in software engineering, the answer is that it depends, right?
Oh, okay. Thanks.
Are there any
Okay.
other questions?
No. I think there's no question for now. So if you have a question, you can drop on the chat, and then he will be there to answer your question for you. Yeah. Yeah. Okay, so thank you, sir. This is very wonderful. So we are moving to our next speaker. Sir Frank, he's a principal software engineer. He's going to talk to us about how we can get started with Azure and .NET. So, sir, if you can hear me, you can get started, and then we take it from there.
Okay. All right.
Yeah.
I'll try and be very quick, but I'll try and deliver what I need to. So yes, so the topic is getting started with .NET Web Apps and Azure. Can I see by hands if we have any web developers here? Any web developers? Okay. So, okay, Peter, great. Okay, cool. All right. So we are going to look at how we can quickly build web applications, right, using .NET framework. There are so many web application frameworks around there. There's the PHP stack, which has its own frameworks, Laravel, etc. There's Django for Python. There's Node.js, and stuff like that. but we are going to focus on .NET since this is a .NET meetup. So I'm quickly going to take you through, let me share my screen, how you can quickly build a web app as a .NET developer. I'm a very big fan of Microsoft Notes, so I put everything in Notes over here for you guys. So first of all, to start with application development in .NET, you need to understand what the .NET framework is. Okay, so the .NET framework is a set of libraries Microsoft or the open source community has developed to allow us developers, build applications, right? So for you to build any application in the .NET stack, you need to have the .NET framework installed. Okay, so first of all, to kick off as a developer in the .NET ecosystem, you install the .NET framework. To get the .NET framework, you can just go to dot.net if it still exists.
It does.
So, it's removed, eh?
No, it does.
Or
it
you
does.
can just go and Google. It does, okay. So you can just go to .NET, right? You can download the .NET framework. Now, the .NET framework allows you to build web applications, mobile, cloud, microservices, artificial intelligence with AI, ML. There are so many things you can do as a developer, right? But we want to focus on web applications, right? So Microsoft has an web application framework called ASP.NET Core, right? So that's what I'm going to take you through and how to build and quickly deploy it using Visual Studio Code. So you download your .NET framework, you install it. Once you download and install your .NET framework, the way you can check if you have your framework installed is, I think you can do .NET as version. This should return the version of the framework you have installed. So this is what I have installed, right? So once you get the .NET version showing, it means that you have the framework installed. Now, what we want to do is we want to get familiar with the command line interface, right? So once you install the framework, it comes with a command line interface that allows you to be able to, create your web apps and all that. We are focusing on web apps, right? So you can just check what options you have in creating a web app by just typing .NET. You always start with .NET, then you can type web .NET new web app, then you can put an H flag, which is help, right? So this shows that this is an ASP.NET Core template, and it's a template for creating ASP.NET Core applications, right? So all these options here are options you can pass to the command line. So to use it, you can type .NET first, what do we want. You put in your options. These are the various options we have. -N, you can put in the name of the output folder. There are so many options. Then you can also pass in a template option, right? So if you want to know what this command line does, just pass the -H parameter, which will give you how to use this template. But since we know what we want to do, we want to create a web application. So we are going to create a new web app that has authentication. So what it means is that a user should be able to log in and should be able to register and log in. So we will pass in a parameter called authentication. So we already know the .NET, we put in the new, we want to create a web app, we pass in authentication, and the type of authentication we want to use is individual authentication, right? You can also choose to pass an output directory if you want to. So let's quickly see this in action. Let me clear my screen. I already created a folder. So let me just create a new one. So I'm in my directory fodo. So what I'm going to do is I'm going to create a new directory for this project. So mkdir, let's call this Accra.net. So I've created a folder called Accra.net. I want to change into Accra.net folder. Then this is where I want to create my web application. So if I go to check the directory, there's nothing over here, as you can see, 0 files. So now let's create a new web application. So we said we'll go .NET new web app, but we want to pass in authentication so that this default web app that will be created for us would have a registration and login feature pre-built. So we are going to pass in the auth parameter, and we want to use individual type of auth. We'll press enter. Now the CLI is going to start scaffolding our project. So it's done. So now let's type dir, let's see. So we can see we have a bunch of files. So it means that our application has been created. Very, very simple, very, very fast. Now we are going to use Visual Studio Code, which we all know is an IDE, let's just call it a text editor for now, for writing your applications. So now I want to open this in Visual Studio Code. So I'll just type code space and a dot, right? This is going to open our new web application inside Visual Studio Code. Yes, I trust the author. So now I'm sure we are all familiar with this presentation or this experience. So we have our Accra.NET project, and these are the various files or for our web application. Today, we are not going to go too deep into the web apps. We'll probably do that in subsequent meetups. But basically, this is how your folder structure, looks like. Now, to run this application, we can just use the command line .NET run. So it first of all starts building your project just to make sure it compiles well. Once it compiles well, it's going to run this project. So it's compiled successfully. It's running now on my local host. So I can click, as you see, this HTTP. I don't have an HTTPS. There's a way to set up a developer SSL certificate if you want to. But because of time, we are just going to look at how to run this quickly. So now, as you can see, this is my web app. Just by running a few commands, I'm able to now, it has a register feature and it has what? A login feature, right? How is this possible? This currently will use SQLite, right, to sort of like save. So as you can see, it's created some migrations. I don't want to go deeply into this, but it's going to use SQLite to save. If you try and register or create any user, let's see if we can do that. It says there's no external, so we are not configuring any external authentication. Let me just see if this is going to work. I'll put in, let me create a password. Do I need to migrate before? Let's see. Okay, so it says this, it's a registered confirmation. So this registration was successful. But because it's not a fully built application, you just need to click this link to confirm your account. If you were building this into a full app, you'd have written extra code to send a confirmation into an email address and all that. But the default template, you just click this to confirm your account. It says, thanks for confirming. So now let's see if I can log in. So what email did I use? I have so many emails. Frank, I think I used my Outlook, right? Yes, yeah. So let's try and log in. Let's see if this will be successful. So it says, hello, Frank. So I'm logged in. So just by running some few commands, I've been able to create a web application, right? And the code for the application is here. So if you go to the www root, you see your CSS files, you have your JavaScript files, you have your libraries, right? The previous presenter had talked about libraries. So these are libraries that our application is dependent on now, right? Now, when I go to pages, right, I can see all the pages. So this is our index page, right? It says welcome, learn about. So if I change this to welcome to Accra.NET meetup, if I save this and I come to the command line, let me just run this again. You realize that our web page would have changed. There are certain tools you can install just to prevent you from rerunning the web server. So it says, welcome to Aqua.net meetup, right? So now what do we want to look at next? So we've seen how to create an application we've seen how to install, how we can install .NET, check whether a framework is well installed. We've also looked at how to use the .NET web app template. We've seen the various parameters it has. We did that by creating a new web app. In creating a new web app, we realized that it was building. So anytime you want to explicitly run the build command, you can just do .NET build. Then we also use .NET run to run our application, right? So in doing all this, we're able to create an application with authentication. I went there to register, it worked, and I was able to log in. So now let's get familiar with Visual Studio Code, and let's see how we can integrate it into Microsoft Azure. I like using documentations a lot. If you are not familiar with Microsoft Learn is where Microsoft has documented all their technologies. So I'm really a big fan of Microsoft Learn. And you can also contribute to Microsoft Learn if you want to. In case you see any mistakes in the text or in commands, you are free to contribute. It's on GitHub. You can sign in and you can make your contributions. Okay, so we want to look at what an app service is. Microsoft has a cloud platform called Azure. If we are all familiar with Microsoft Azure, that's Microsoft's Azure, that's Microsoft's cloud computing platform. Okay, so Microsoft Azure allows us to deploy our applications. It gives us infrastructure to deploy our applications. So there's infrastructure as a service and platform as a service. But we are going to look at a service called web app. Web app is what we call a platform as a service, right? So it basically allows you to quickly deploy applications without having to think about the underlying servers or managing all those servers and those configurations, right? And as you can see, you can host a variety of applications on a web app. So it's not only .NET Core, you can also host Java, Node.js, PHP, and Python. That's the good thing about Microsoft Azure. Microsoft Azure is cloud for all. So it's not only scoped to .NET, right? You can use other platforms. So now, why do you want to use an app service? So first of all, it targets multiple frameworks. You've seen that. And it's also a managed service. So what it means is that you don't need to worry about all the other things that are behind it. Okay. So now let's look at how we can use an access. First of all, you create a Microsoft Azure account. In creating a Microsoft Azure account, you get $200 free. So you can do that right after this meetup. Create a Microsoft Azure account, you get $200 free. Now, once you finish creating the account, come to your Visual Studio Code and go to extensions. Okay, I'm going to show you the easiest way to deploy your application. You go to extensions. I have a number of them installed based on what I do, right? But what we want to focus on is an extension called web. You can install the Azure extension, or you can specifically install the web app extension, right? So what I already have here is I have the Microsoft Azure extension. So to install it, you come to extensions, you look for Azure. This is it, Azure Tools. So if you install the Azure Tools, it's going to install a bunch of extensions. You might probably not need all, right? You might want to go in and specifically install what you want. Probably you're not using container apps. You are not using all those kind of extensions, right? So you can just go there and be specific, or you can just install all the Azure Tools. So if I click on Azure Tools, this is the extension pack. It comes with 8 extensions. So the first one is what app service, right? I've already installed it, but if you haven't installed it, this would show as install. So you click to install this, then it's going to install the Azure Azure Tools extension. I'm going to get app service. So because I have this already, I'm going to click on it. I've already installed it. So once you click on the Azure extension, it's going to ask you to log in, right? As soon as you log in, it's going to show you all the workloads that you have, all your workspaces, your account. So just give this a minute. It's going to log in. Okay, not now. So as soon as it displays my resources, what I'm going to do is I'm just going to quickly deploy this application that we've created. So look at this. I have a number of subscriptions. So Azure works in a way that once you create an account is tied to a subscription. So I already have a subscription. So I have so many subscriptions, but the one I want to use is what I call the CSP subscription. So once I click on it, it's going to expand and show me all that I can create. So this is connected to Microsoft Azure. I can create databases, logic app functions, but I want to create an app service because I want to deploy my application. So it's as easy as connecting your extension to Microsoft Azure. You come to app service, you can right click app service and say create new web app, right? I want the simplest template. There's an advanced template, but this is the quickest one. So I'll click on create new web app. And this is going to start a process for me to create a web app in the Microsoft Azure cloud. So I need to give it a globally unique name because it's going to give me a URL at the end of the day. So let's call this Accra ACCRA.net meetup. Let's see if this is unique. If it's not globally unique, it's going to flag. So let's just try this and see. So it's trying to search, okay, it's globally unique. So nobody has this at this point. Now it's asking me to select my runtime stack, right? You can see there's Python, there's PHP, there's Java, right? But we are using .NET. And even with .NET, you need to be able to specify which .NET version you are using, right? When I checked from here, my version was what? I was using version 8. Okay, I think I cleared that. I was using version 8. So I'm going to select the version 8, right? And there are a number of tiers. You can have a free tier, you can have a basic tier for developer and testing, and there's a premium tier. I'll just go with the basic tier for now. So as you can see, it is creating my web app. I can expand this and see the existing web apps I have. Currently, I have only one called Demo Web App 233, right? Now I'm creating a new one called Accra.net, right? Meetup. So it's going to create this web app, this app service. And once it's done creating the app service, we can now publish our application to the cloud. So this is our application source code. We've already seen that. And this is our Azure extension, right? So I'm doing everything within Visual Studio Code. I'm not moving out or even going to the web to connect to it. It's very easy to connect to your app services using the extensions. So it's trying to create a web app. Once it's done creating successfully, I can now publish my application to the web app. So let's just give it a minute. If there are any questions, we could ask at the moment whilst we create the web app. So it's still creating. I think it's almost done, 7 out of 7. So this is probably the last step. It's succeeded. Do you see that? So Accra.net. So now it's asking me, Visual Studio Code is intelligent. It's saying that I've created a new web app called Accra.net Meetup, right? Now this is the URL I can access the web app from, right? Can I copy this? Okay. So it's asking me, do I want to deploy this application? Because it's realized that I've created a new web app and it's asking me whether I want to deploy. I can choose to click deploy. So it's asking me, what do I want to deploy? We want to deploy this our application, right? It's in the folder Accra.net. That's what we created. So I'm going to click on this. Required configuration to deploy is missing. Let's add the configuration and it's going to start deploying. So let's look at what the site looks like now. Let's go there. It's Accra.NET meetup .azure websites.com. Do I have the URL right? Accra.NET meetup .azure website.com. Okay. So let's see what we have here. So anytime you create, okay, this is wrong. Let me cross check it. Let's see what so as you can see, it's deploying. But I wanted us to see what it looked like before. Accra.NET meetup. Accra. Oh, I made a mistake. The Accra was 3 C's. So ACCRA.NET meetup. Okay.
I think you have a couple of hands up.
Okay. Let me take those questions. Yes, please go one by one. Let's ask those questions. Let me try and navigate to .NET. So, you can ask the questions, please.
Okay. I think there was also a question on the chat. Someone is asking that is Azure for only .NET developers?
No, it's not for .NET developers. So as you can see, on the right time, we're able to select, okay, browse website. We're able to select, we had options for Node.js, PHP, and there was also options for Java. So let's go back to the documentation. If you can look here. So these are some of the languages supported here. So Java, PHP, Python. Okay, so this is our website. So Accra.NET Meetup, anytime you create a new application, web app, this is how it will look like, right? But if our deployment was successful, this web application should change. So it's still deploying. And what is it deploying? It's deploying this base template. It's deploying this base template that we created, which is this, right? Which we are running on our local host. So at the end of the day, if that's, I think this is it. Yeah. So if this deploys successfully, this web app should now change to the code that we have. So let's hope it deploys successfully. It's still deploying. So it's 1 out of 4 process, 2 out of 4. So I'll take questions, the other questions, if there are any, whilst it's deploying.
Yeah. So someone is also asking, is this the same process for mobile apps using Azure?
Yes. So for mobile apps, there's a slightly different process, right? With mobile apps, you can build. So .NET has a framework called Maui, right? Before there was Xamarin, but now there's a new framework called Maui, right? So if you want to build mobile apps, you use the Maui framework, and Maui supports Visual Studio Code. So if you go to mobile and desktop over here, you can even do game development with Unity as well, IoT and stuff. So if I click on this, you realize that there is a multi-platform called .NET Maui, right? So if you want to learn more about Maui, in subsequent meetups, we'll show you how to probably build a Maui app. So you can build a Maui app using the .NET CLI, the same process, right? So instead of creating a web app, you create rather a mobile app using a mobile template, right? So you can also do that as well. So yes, it supports a mobile app, but once you are deploying the mobile app, that process is slightly different, because deploying a mobile app, you need to deploy it to a store. So either Google or Android, and Microsoft has a service called App Service. It's called Microsoft. No, it's not app service. I've forgotten the name. It's for integrating mobile development and doing CI/CD using mobile development tools. So we can look at that in the subsequent meetup. Okay, in the meantime, our website is ready. Remember how our old website looks like? This, right? And where is it? This how our old website looks like. There's it, right? But now it's done. So let's quickly. So as you can see, this is our web app that we've deployed now. I shared a link. I'm sure you've been able to access it. Now, what we want to do is we want to see how we can redeploy. I mean, in subsequent meetups, we'll have other presenters taking us through CI/CD and all those things. But for now, it's just a quick deploy. Let's say you're building your own personal website or your own personal application, working alone. So let's just change this text. This is welcome to Accra.NET meetup. I'm going to add user group, right? I don't know if it's one word, but let's just keep it that way. So I'm going to add user group. So as you can see, Visual Studio Code has this white dot up there. For those familiar with this, you know that this means that there is a new change in this file, right? So I'm going to click Control S. So Control S is going to what? Save this change for me. So now that it's saved, you realize that it's gone. But we need to deploy it because it's a new change. Nothing has changed here still. But I want to deploy it so that this will change back to what, let's say, welcome to Accra.NET meetup user group. Just a basic change. We don't need to go do anything complex. So how do we deploy this? So let's go to the extension again. This is Accra.NET meetup. I can right click this and I can click on to web app, right? So I'm going to deploy again. If you use the advanced, to ask you more. Any question in the chat I answered before?
Yeah, someone is asking in
Okay.
Azure, how do you differentiate between web app and website? So I think he's trying to ask the difference between
So
web app and website in Azure.
yeah, so Azure has when we go into the various let me call it flavors of platform as a service for developers, there are quite a number of them. So there's web apps, there's websites. So websites is mostly for, and there's even static web apps. So if it's not an application tied to a database that needs any complex configuration, right, you can use the websites. Okay, but if it's an application, right, a scalable application that you want to build, you need to use the web apps. Basically, Microsoft wants to understand where you're coming from in terms of what you want to do and the right resource that they need to provision for you. Because we said it's a managed service. So at the end of the day, they are creating an infrastructure to host your application. So if you want more information on that, you can just come to Microsoft Learn, right? I always encourage people to use Microsoft Learn. You can come to Microsoft Learn. You can just come and type Azure, let's say PaaS, that's Azure Platform as a Service. So you can see Azure Pass list. Okay, let me just go deep into this. Will be probably give me more information. So just look for Azure Platform as a Service, and you can see all the flavors you have access to, right? So let's see the pass options. So platform as a service means that what Microsoft manages all these services. So if you look over here, they are saying instead of using IIS is Microsoft Web Server, you use Azure App Service, right? So you can just deep dive into all their past services, or you can just come in and just look for things like Azure Web Apps. If you're in Azure already, you can look for, I think it's called, I think they have static, I think it's called static apps. Yeah, so there's static web apps, right? So you can use static web apps. If you want to know what static web apps are, I can just come to Microsoft Learn and just type static web apps here. So static web apps Azure, can do a search. Then let's go, you can go into the documentation and we can see what static web apps are. So if you want to know all the type of services you can use from Azure PaaS, just go into their PaaS offering and just look at them. So one of them is a static web apps. So you can go in and look at what it is, the features it has, and everything. So what you can do with static web apps, so you can see, there's some Angular, React, Vue stuff here. So you can get more information from the documentation. So you can use static web apps. You can use a website, but you can actually build a website like a normal website using the Azure Web Apps. That would also work. So yeah.
Yeah, I think there was no question. Oh, yeah. Can someone hear me? I think my network is breaking. I don't know, but I think I'm.
Yeah, I can hear you.
So,
There's a hand up.
There is a hand up. I do.
Okay.
Ohene, is it Ohene?
Yes, so
I'm not
you want
seeing.
to ask the
So no.
question?
Oh, no. I think I did earlier. Sorry.
That was earlier on. Okay. So then I think we are free to go. Someone is also asking a question. Okay. So I think that one, those question is being. Okay. So that was .NET. So thank you guys for joining. So we hope to see you in our next meetup, which will happen in the next month. So all the information will be shared across all our platform. So if you are here and you are not part of our WhatsApp group, after this event, you can reach out. And then this event is being recorded, so we are going to upload that one on our YouTube channel. And please do subscribe to our YouTube channel for us, and then you can share this content to others so that they can also learn what you have learned today. So thank you everyone for joining. We'll see you next month. And if you have a question, all the speakers are available to answer your question. You can reach out to them on the social media platform, or you can reach out to them on our WhatsApp platform, and then they will be able to help you to learn. Further. So thank you for joining. At this point, we call it a day. So I'll see you in